Let's go. So this is our project tracking trains across the Midwest. Basically, it's just as what the title says. We decided to take 4 states from the Midwest: Nebraska, Iowa, Kansas, and Missouri, and try to represent some sort of train travel across them, as the Midwest is one of the most common areas for train travel. And we had the state set up with some tracks of trains along with stations, and then the trains would travel across the stations. We did choose accurate train station and track locations based on actual Amtrak data, and then we decided to use that to query positions of trains and so forth. And then, so this is what we started with. We have our 3 kind of main different areas or relational schemes. We have their trains with their different IDs, and then we have the stations, the tracks, and then we have the relationship of the train travels on the tracks, and then the tracks are connected by the stations, which the trains also stop at. And then we have the different categories for each of them.
For the database schema, we have train, station, track, and train schedule. And each of them have their unique IDs. For example, train has train ID and station has station name as the primary key. And using this, we plotted the data in MLPQ. For our data source, we have the original trains, tracks, and stations, which are being picked from the real map that was provided in the Amtrak website. And for the trains, we pretty much Googled to find the train names and their information. But the train schedule is not real, and it's been synthesized. For the state maps, that's a real data which was traced using the MATLAB script that was provided in the class. And this is our representation in MLPQ. We have 4 states: Nebraska, Iowa, Missouri, and Kansas. And we have 2 tracks that go across these 4 states. And we have 4 stations, and we have 2 trains, 3 trains. And this is the video. As you can see, the trains are moving to the opposite side of the tracks. And on the top track, 2 trains go in opposite directions, and on the other track, there's only 1 train that goes from left to right.
All right. Then looking at the queries, the first query we did was to see those trains that were scheduled to arrive in Burlington. So to do this, we queried both the train schedule relation along with the train relation. And Burlington was that station you saw at the bottom right of Iowa. So we knew there was going to be 2 trains there. So we queried these to find out what times exactly and the details of the trains that were going to or being at Burlington to find their data. And you can see that we have 2 that ended up showing, 1 that was there at time 0 and 1 that was there at time 2:30, and their information. For the second query, we wanted to do more just positional work, so we queried specifically for train 1 to see where it was specifically at position T50. And you can see what we ended up getting is these 2 constraints. And this occurs because as our trains are in rectangles, they require multiple constraint relations. So this is, even though it's the same time, it's just 2 representations in constraint relation for that 1 train. And then we've got query 3, where we were trying to find the number of unique train models in service. So to do this, we were using the count aggregation. to find the different train models as the count aggregation both does count and also it has a built-in distinct function for it, which returned that we had 3 distinct train models, which falls in line as our data had 3 models: the Acela Express, the Siemens Venture, and the Avilia Liberty. And lastly, we also wanted to find time that those trains cross. As Ricardo mentioned, those top trains on that first track there intersect at a point. So to do this, we were finding the time at which these 2 trains have fully passed each other, and at that last time their x values intersect. To do that, we created had two versions of train from those specific train IDs, which are 2 and 3, and then took where their x values were the same, took the max time there.
And then, so those are all the queries we had. As for future work, this was kind of a smaller scale. Eventually, we could go maybe even greater across the states, maybe even from the West Coast to East Coast. And then we could also go beyond just select tracks from Amtrak data and also focusing more on the accuracy of time train schedules and all that. And then also change up the representation of the trains on the map, maybe have some more variety of how they're portrayed with the tracks. And that brings us to our project. Thank you.
Is it one?